Welcome to Case Study Series in Operations Management Case Study by Skilled MBA Clean Air. Limited faced cash flow instability due to inefficient supply chain practices. By implementing scientific demand forecasting techniques, they aim to stabilize finances. This approach involved analyzing historical data, market trends, and customer behavior to predict demand accurately, ensuring optimal inventory levels and reducing waste. Clean Air. Limited faced cash flow instability due to inefficient supply chain practices. To address this, they implemented scientific demand forecasting techniques. This approach stabilized financial operations, improved supply chain efficiency, and provided valuable insights for future applications. The case study highlights the importance of precise demand forecasting in achieving operational excellence and financial stability. Clean Air Limited is a leading Indian manufacturer of emission control systems with a strong presence in both automotive and industrial sectors. The company is committed to sustainability and environmental compliance, operating within a highly regulated and technically complex industry. These factors contribute to the challenges faced in managing cash flow and inventory effectively. Inefficient inventory management has led to excessive stock of some components and frequent stockouts of others, causing production bottlenecks. Procurement decisions rely on intuition instead of data-driven forecasts, resulting in a lack of demand visibility. This ties up working capital in excess inventory, while emergency purchases strain profitability. In January 2024, the General Manager of Sourcing and Supply Chain was tasked with stabilizing cash flow through improved planning and inventory management. This mandate followed 3 quarters of declining free cash flow, despite steady revenue growth, highlighting the urgent need for strategic changes in inventory practices and demand forecasting. The General Manager enrolled in a supply chain and logistics management certification program focusing on root cause analysis. This revealed inconsistent sourcing and outdated inventory practices as primary issues. The solution identified was scientific demand forecasting, crucial for addressing these supply chain challenges effectively. Data analysis revealed reactive order placements and a lack of systematic supplier lead time evaluations. Coordination between sales and procurement was absent, leading to irregular production scheduling and increased overtime costs. Additionally, there was no visibility into seasonal demand patterns, resulting in inefficiencies between inventory costs and stockout incidents. Implementing scientific demand forecasting involved collecting 36 months of historical data, standardizing formats, and addressing data gaps. Seasonal trend analysis identified quarterly demand patterns. Various forecasting models, including moving average and ARIMA, were tested for optimal fit. Outputs were integrated with the Enterprise Resource Planning System for automated planning alerts, enhancing decision-making efficiency. The master production schedule was crafted to synchronize procurement, inventory, and production. Procurement focused on optimizing order quantities, strategic supplier negotiations, and enhancing lead time visibility. Inventory management included safety stock calculations, ABC classification, and storage optimization. Production efforts centered on level loading, capacity planning, and resource allocation to ensure seamless operations. Quantitative forecasting techniques were crucial. Time series analysis revealed cyclical demand patterns linked to emission regulations. Statistical models, including weighted moving averages and exponential smoothing, were applied to stabilize forecasts. Scenario planning developed best, worst, and most likely scenarios, enhancing resilience in planning processes. Operational improvements led to a 28% inventory reduction, enhancing availability of critical components. Stockout incidents dropped by 65%, minimizing production delays. AR's 4.2 crore working capital release was achieved by reducing excess inventory. Forecast accuracy reached 93% for A category items, ensuring reliable demand predictions and efficient resource allocation. Enhanced supplier relationships stem from consistent order patterns, leading to improved production scheduling and fewer emergency changes. This results in better customer service with reduced lead times. A data-driven decision culture fosters strategic resource allocation, boosting confidence in business planning and forecasting. Successful forecasting hinges on cross-functional integration, requiring collaboration from sales, operations, finance, and procurement. Prioritize directional accuracy over precise numbers for effective planning. Emphasize robust processes over sophisticated tools for sustainable improvements. Regularly review and adjust forecasting models to adapt to changing business conditions, ensuring continuous refinement and alignment with strategic goals. Scientific demand forecasting has evolved into a catalyst for business transformation. At Clean Air Limited, supply chain enhancements stabilized cash flow and shifted decision-making from intuition to data-driven strategies, revolutionizing operations. This approach underscores the importance of integrating forecasting into broader business processes for sustainable growth. Thank you for your attention. For more insights into supply chain strategy and operational excellence, visit our website or follow us on LinkedIn. Contact us at support@askilledmba.com or +91 87553 00795 for further inquiries.